Hi, it's Terry Dennery of the MathWorks. So I suggested I might do a third video in this series. Now I'm thinking even a fourth one, but definitely a third one, right? And I give it a little bit of thought and decided it's a really good idea, right? And so we're not going to do anything really different from what we did in the previous two videos, but we're going to use an approach that really can, I'll just say, has a lot more runway. We can take it much further, right? And I think it will be evident from this video, but there's lots of videos where I've kind of taken this more visual approach to mechanics, and I've used this very good tool called SimWise 4D to do it. Right, and it's because there is a tool called SimScape Multibody, which allows you to take a classic multi-body approach where you describe mechanical systems in terms of bodies with mass and inertia and so forth, joints and coordinate systems for defining location and orientation of joints. Very kind of physical description approaches that this works so well. All right, and so anyways, without further ado, let's just kind of go with this. So I'm going to kind of erase kind of the history, just kind of start this over. But the basic idea is that we're going to work with a body. In this case, I chose a sphere, and its principal parameter is going to be its mass, which we might recall is 2 kilograms. Now there's also the spring. I think you can kind of see it there, and I'll open that up. We'll see the same spring constant and damping constant that we've been using. And so with that, I'll just kind of hit run. And I think you'll recognize this response. This is the response we did with our direct solution to the differential equation. All right. So anyways, I won't advocate too much in this video, but certainly there's really good advantages to this kind of visual approach provided by SimWise. And so, of course, there's great utility in having all this inside Simulink. And so I created this app called Get Geometry, which is going to take that pretty fundamental description of bodies, joints, and coordinate systems that can describe pretty much any mechanism, bring it into Simulink, and then from that build the Simulink model using the SimScape multi-body components. So we'll just click on that. Import to Simulink. Here's our model. We're going to see our data brought into the workspace. And then we'll see SimScape multi-body blocks representing that system. Let's hit run. Let's reset that. Let's make it smaller just so we can kind of see the overall movement. So it kind of goes up and down. Right? And very nicely, SimScape multi-body retains a visual, kind of video creation so that we can kind of see it moving too, right? But again, it's good to kind of see those signals too. And so I'm going to go in here and I'll choose to measure the position. Okay, this is a vertical constraint. It's going to allow it to move only up and down. There's a good reason for using it. Perhaps we'll talk about it. Maybe we won't talk about it too much at all. But let's go ahead and kind of take that position right now. And we're going to put it into a scope. And so we convert it from a physical signal to a standard Simulink signal. And we'll send it into a scope. And we'll hit run. Usually with those PS2 Simulink blocks, I like to talk about units. I won't do that in this video just because we're going to be working in metric, and so all the defaults on those blocks will create SI units like position will be in meters and mass in kilograms and so forth, right? And so, anyways, I can kind of see that that's exactly what we got in our previous video as well as what we got when we just ran inside SimWise, and I can assure you that it is. And the idea of where I'm going with this is that I want to kind of show that this approach fits real well with where we left off in the last video, right? And so I just kind of copied that model that we finished with, renamed it just so those who want to kind of use the previous model will have it available to them. But here's basically that model. I think we need to bring our data in. You'll recall we defined our data in a MATLAB live script. And let me hit run, and you'll see mass is 2, spring constant's 100, damping's 10, so forth. And here's where we finished off in that last video. Right, so we basically controlled it so that the object starts off at a position of 0 and vertically rises according to our trajectory to a position of 5 meters. Right. And what we want to do is really kind of match this. And it's like we want to be able to send force in, and we want to measure position, velocity, and acceleration, which will be used in this kind of feedback controller. Right. Now gravity is kind of already kind of put into our block, and so I'll just kind of not go too much into detail on that, but just kind of acknowledge that it does exist already, right? And so we got position, but we want kind of those other things to even make this a little bit bigger, so there'll be nice room to get signals on velocity and acceleration, because our goal is to express it as PVA. Oops. You might recall we used what we call mux block to bring those 3 signals together into one 3-component signal. Good enough. We'll call that one signal PVA. All right, the other thing we needed to do is let's put that force in. And so that's an actuation, and we want to provide that force via a signal. And so now we got a signal port here too. Oops, of course. It's looking for a physical signal. Right? And so I'll start typing the word Simulink, and it'll give me that as the first option. And again, it's metric, and it's going to presume what I want, which is force to be applied in units of newtons. Okay. Then finally, we got rid of the spring damper, and so, there are various kind of philosophical conversations you might have on where you might want to get rid of that spring, but keep it consistent with what we have in SimWise, but certainly this will work, right? And so I delete that spring and no longer need this, and I'm almost there, right? And so what I want to do is shift select those two, and let's just kind of bring those up to this level too. Okay, and with that, I will create a subsystem which will have force going in and PVA coming out. And I'll just call it multi-body mechanics. All right. And so I want to copy that and I want to paste it in here. Right. And if you don't know about it, I like this. I always do this. I'll go to Format, and I will match the size of those two blocks. Gravity is a good conversation. I might kind of get into this a little bit more in maybe some other video, but for right now, I'm just going to acknowledge that the gravity's already been defined in this. That's why it worked as well as it did. And so I'm going to just kind of take that and then replace it in. And I'll hit run, and let's kind of see how we do. Okay, it went off screen, so let's make it a little bit smaller. And let's see if we can kind of follow it a little bit better this time. Right. And a little bit of scaling to get all that right, but I'll certainly, again, say it's awesome that I can kind of see it moving. And I think the last thing I might do on this, is just kind of jump in here and kind of use that same kind of data description that we were using before. And so mass and inertia, and instead of calculating via geometry, I'll just say custom, and here I'll put in M for mass. Oh, yeah. Never, ever, ever accept this kind of stuff. 001. Here's what I'll do. So I wanted to, that's a good one. And again, it's kind of why I do things inside SimWise. So I think I'll just kind of go back to where it was, which is, oh wow, the geometry and the density to choose it. All right, and I think I'll wrap up the video right there then. I'd say that last little thing I went through, it is going to kind of point to the idea that, well, you're defining mechanics in two different locations, and there's a very wise, I'd say, best practice that simulation people like to stick to, which is define your data once and define it all in one place. And I'll just say that over the years I've evolved is when I do bring in stuff from SimWise, SimWise is the place where I will define mass and mass properties and so forth. And what we're truly getting is a snapshot that's very well represented inside Simulink, because we do have a tool called SimScape Multibody. I'm sure somewhere on our MathWorks website you'll see words like the one truth. Okay, and in this case, the one truth for mechanics is going to take place in SimWise, and until ultimately, is perhaps we'll get into deeper demonstrations on CAD import. I think that CAD import or CAD tools like SolidWorks, CATIA, things like that. That's truly where your one truth for mechanics is. Anyways, encountering that last little point, I won't pontificate too much further on that, but it's certainly a theme that will come up in a lot of my videos. So anyways, thank you, and I think there will be another video. Thank you.